Okay, question 4. Two sinusoidal waves traveling in opposite direction interfere to produce a standing wave as given by this equation here. So y and x are in meters and t is in second. So for the sinusoidal waves, calculate the wavelength, frequency, and speed. Okay, so this equation now is a standing wave punya equation. It is no longer the progressive wave punya equation. Okay, so from here we can actually calculate the wavelength by using by using the wave number lah. But let me just compare this with the general equation, which is y equal to 2a cos kx sine omega t. Okay, so the value of wavelength can be calculated by using the wave number. So lambda is then equal to 15.7 meter lah. Okay, so this is value of k, this is the value of omega, this is 2a, which is the amplitude lah. Okay, and then the frequency, so we can use the formula of omega, which is equal to 2 pi f. So the frequency is then equal to 31.8 hertz lah. Okay, and then lastly the speed is v equal to f lambda. So this is just 500 meter per second. Okay, and then question B, two waves in a long string are given by this equation here. So y1, y2 are in meters and t is in seconds. Calculate the position of the nodes of the resulting standing wave, and then maximum displacement in the string at x equal to 0.4 meter. Okay, so we know that nodes occurs when y is equal to 0 kan? So nodes occur when y is equal to 0. Okay, so we can actually use the formula. Which formula sudah tu? Wait okay, sorry. Before we do that, we have to actually find the standing wave punya resulting standing wave punya equation, which is basically y1 plus y2 lah. Okay, so this will be 0.04 meter, 0.04 sine cos kx. So k is x over 2 sine omega t, which is equal to 40 t. Okay, so that is the resulting standing wave punya equation. So we have to find the position of the nodes. So nodes occurs when y is equal to 0. So we can actually use the formula. Which formula? Let me show you which formula. This one, where we have to find the value of nodes. Okay, so nodes would occur at point with displacement y equal to 0. So we can actually use this formula lah. Okay, let me show you how to do it. Okay, so nodes will occur y equal to 0. So x over 2, which is the k, then 2n plus 1 pi over 2. Hence x will be equal to 2n plus 1 pi. Okay, so it will basically occur at odd numbers. Pi, 3 pi, and then 5 pi, and then so on. So it will occur at that point lah. Okay? So yang ini ni when y equal to 0. Okay? Boleh faham kan ya kamu? Basically the punya solution is kind of similar to what I've shown you here lah. Untuk kamu cari notes ah. Kamu boleh start dari sini supaya kamu dapat faham what are we doing in that question. Okay? Alright, lepas tu dia punya, we have to find the what do we have to find? The maximum displacement in the string. So maximum displacement occurs when sine 40 t is equal to 1. Okay, so it will occur when sine 40t equal to 1 lah. So we can then let y equal to 0.04 cos x over 2. Yang sini dia jadi 1 sudah lah. Sine 40t itu jadi 1. So we can then substitute the value of x to be equal to 0.4. X equal to 0.4 lah. Sebab dia sudah tulisan akan x equal to 0.4 meter. So substitute, you should then get the maximum displacement to be equal to 0.039 meter. Okay? Alright, so that is how you solve question 4b.